In our data-driven world, non-volatile storage plays an enormous role in pulling all of that data together. But within that non-volatile storage, solid-state storage has been playing and will continue to play a larger and larger role. Within that, the hyperscale data center is a dominant player, and they use storage differently. Their data centers are application-driven, which by extension means software-defined. The data center being software-driven, there are many opportunities that are yet to be addressed. Latency is obviously something that we're all continuing to try to drive down. As you do that within the traditional solid-state storage, every once in a while, you'll get an outlier. So of these two options, which is better? The smart guys out there will say it depends. Depending upon that workload, you may want to dial it down. You may want to be able to position things for speed. And the application needs to be able to make that decision. Another opportunity is workload isolation. In the data center also, you may have a chatty I/O that can interfere with other streams, and the ability to isolate those streams. And in fact, in today's world, thousands of streams that are coming in simultaneously is another opportunity. In the data center, you may be running different kinds of workloads in parallel, simultaneously. And the simultaneous model is probably the more likely one. One opportunity that has not yet been met is to be able to make the solid-state media dynamically reconfigurable to best meet the needs of the workload that is coming through. Low-level control is also an item that is quite important. When you're trying to tightly orchestrate things within the hyperscale, there are some things that do need to be controlled. How you place your data, when you start and stop garbage collection, how you manage your ECC and RAID. These are some of the features that are typically low level that need to be managed. And that needs to be done in a way that doesn't tie you to a single vendor or a single technology. Now, because these are real problems, there have been different attempts to address them in the market. Some of them have been trying to modify a traditional drive. Well, it's really hard to take a minivan and turn it into something different. And there are people who really don't want to take a box of nuts and bolts and make something customized. So there really is a need for something different, and that is software-enabled flash. Software-enabled flash technology fundamentally redefines that relationship between the host and its storage, particularly the solid-state storage. Does that through an open source flash native API where the behaviors are defined. There's powerful offloading from the host CPU of the low-level functions that together gives the host full control and ease of use.